2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow. Why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics that will be just the grade 11 and grade 10 statistics are not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be a 90. That is 110. 125, 135, and then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an object this side and see. Okay, so if we have this as our, let's use this color. Perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay. So 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay. And then we have 90, 90, 90, 90, 80, and then this is our 90 with a 14. somewhere there. And then we have 110. This 100. 110 must be just in the middle there. For the 15, somewhere there. Okay, I hope it comes out. Then we have 125, 135. 125 is somewhere here. Okay. Then we have 135, slightly above that. And then lastly, we have 140. Guys, please forgive my graph, the way it is looking. Okay, then I'll connect this using the freehand. Okay, up to somewhere there. And then we just need to extend this to the starting class, which is the 8. So that is the algebra for the cumulative frequency graph that the question is basically looking for. All right, then determine the 5-number summary of the delivery times from the algebra. Why? Okay, so we know that from the algebra, we need to get the minimum, okay? We need to get the maximum. We need to get the Q1, we need to get the Q2, we need to get the Q3. So we know that our minimum is 8 o'clock, no? Our maximum, we say that is 8. Our maximum is 1800. Okay, so the median, we know that half of 40 or half of 140 is 70. And 70 is somewhere around here. So if I draw a line and then it meets somewhere there, you can see that it is somewhere around the 13,5 or 13, something. Not so accurate, but that is the kind of time I'm ending up with. So I can say that my Q2 is a 13, let me just take 15 to be precise, but it's around 13, something. Then Q1, which is a quarter of 140. Okay, so 140 divided by, saying 140 divided by 4, which is a 35. Did we have a 35 in our cumulatives? 35? No. Let's just look at the graph and then we'll see. So 35 is somewhere around here. You draw the line up until it meets that. We're seeing that it is going to be after 11, okay? So we can say maybe that is 11, maybe 36 or 11, 30 something. Then our Q3, what is 3/4 of 140? Okay, so it's saying 140 times 0, that, which is 100. Eh? So where do we find 100? Is 100. You draw a line, miss the graph, and then you're getting it after the 14th mark or the 14th hour. So meaning that it's around 14 something. I'll say 1430 or sub, depending on how the graph will look like, okay? But remember, I don't have a graph. That's why I'm taking just estimates. Then they want us to draw the box and whisker. Okay, so let's see. My lines need to be investigated. Why are they so skewed? Okay, let's have that. So if this is our minimum, which is 8, this is our maximum, which is 18. Okay. It's not going to make sense. Not making sense. So let's have 8. We have 10, 12, 14, 16, 18, and maybe 20. You say the minimum, this is the maximum. Our Q1 is 11, something, which is somewhere there. Our Q2 is 13 something, which is somewhere there. I'll put it somewhere there. Our Q3 is a 1430, which is also somewhere there. Then I'll just have my box drawn, and then I'll connect this. Then I'll connect that. So this is our box and whisker. Now, from my box and whisker, because I know the question is asking to comment on the skewness. So we can say that there is more space between the Q1 and the Q2. So it is skewed to the left. okay, skewed to the left, or is negatively skewed. Then they're telling us if the store owner appoints 2 more drivers, the number of deliveries increase by 4 every hour. What influence will this have on the standard deviation? So for as long as the effect is uniformly distributed, the standard deviation will stay the same, okay? Can say stay the same, or we can say it's not affected, as long as it is uniformly done. But if it's done for just some others and left out for others, then they'll definitely have an effect. All right, then question number 2, which is the box and whisker. So they're telling us the number of push-ups that can be made in 1 minute by the first team rugby players of a certain high school will be recorded. Box and whisker given below. So this is the minimum, this is the median, this is the Q3. So if the range of the data is 36, determine the maximum number of push-ups. So we know that range is given as the maximum minus the minimum. So if we want the maximum, we must get the range plus the minimum. So our range is a 36 plus the minimum, which is a 49. So what is a 36 plus 49? 36 plus 49, we're getting 80 what? That is 85. Okay, so this is 85 there. And then determine the lower quartile value if the interquartile range is 20. So we know that interquartile range, IQR, is the same as Q3 minus Q1. So if that is a 20, our Q3 is 75 minus the Q1, which we don't know. So switch positions, meaning that Q1 is going to be 75 minus 20, which is a 50 what? It looks like a 55. Okay, then 2.3, we have 2 players. Okay, 2 players that had the same number of push-ups. They did 8 more push-ups than the median value. Determine the number of push-ups that they did. Okay, 8 more push-ups than the median. So we know that the median is having a value of 64 push-ups. So what is 64 plus 8? Does it make sense? It is 72. This question is giving Metlit vibes, ne? Yes. Okay, then 2.4, the average number of push-ups is 65. Comment on the skewness. The average. So average, I mean, how does it connect with the skewness? Okay. Unless if we look at how the median relates with the mode, but that's not important for this particular question. Okay. But let's see. If the 65 is greater than the median, but we said our Q1 is a 55. I don't know. Let's see. What is 64 minus 55? Because I don't need to use that whole thing. This is going to be a 9. And then this is going to be 11. So there's more space to the right. No? So I'll just say it is skewed to the right. The reason someone will say that the mean is greater than the median, which is the Q2. All right, then 2.5, the standard deviation is this. Determine the number of players whose push-ups was less than 1 standard deviation. So to be less, we need to get the mean, okay? And then you subtract the standard deviation. So the mean is 65 minus 10.91 or 10.91. So 65 minus 10.91, which gives us 54.09. Is that what the question is asking for? No, that's not what the question is asking for. The question is asking us how many players will have that. But we have the push-ups of the players in a certain high school. The box and whisker is given below. The range is 36. Do we know how many players are there? Nope. 2 players have the same push-ups, they did that. Well, we don't have the number I don't know. Is there something that I'm missing? Any annexure? Nothing. So it doesn't make sense for them to ask us about the number of push-ups if they never gave us the push-ups in the first place, because this box and whisker simply represents a summarized sort of version. So this is what I'm getting, but I cannot draw a conclusion as into how many was determine the number of players whose number of push-ups. This question is kind of vague for me. Okay. We move on to question number 3. Okay, so with the Gauteng people, this is probably where your paper is going to start from, the Euclidean. There's no statistics. Hallelujah. Okay, question 3 in the diagram below. A is -10 and -2, B is 10, 8, and then C is 11, -9 at the vertices of our triangle ABC. Answer the following questions. All right. Can we show that the equation of the altitude? Wow, now they're using big English. The altitude from C, okay, to AB, or from C on to AB is given us this. How many marks is this for the big English? It's 4 marks. Okay, so we know that altitude is basically height above something, yeah? So if, let's say we have our distance, which distance must make a 90 degree with whatever the question is asking for. So they want the altitude from C onto AB. These people. They want the height, technically. Remember, altitude must make 90 degrees with the base. So if this is the base, this is the height, which is the altitude. Okay, so we know that these two must be bisecting perpendicularly, and yes, there's trouble. Way in paradise. All right, so let's see. At least we have the answer. We cannot fail to get the answer if you've already given a hint. So let's get the gradient of AB first of all. Okay, it's going to be the change in Y over the change in X. So that's going to be 8 minus -2 over 10 minus -10. All right, so that is a 10 over 20, meaning that the gradient is what? A half for that. But we know that these two are going to be perpendicular. So we can say that gradient of the altitude is going to be -2, because we know that M1 times M2 must always give us -1. So if that is true, then we can use the point C and say that Y minus Y1 is equal to M into X minus X1. So that's going to be Y minus -9 is equal to -2 into X minus 11. We open that up. It's going to be -2X plus 22 minus 9. So it's a -2X plus, what's 22 minus 9? Is it 13? This is what I'm ending up with. Isn't that what the question wanted? Correct. So the question just wanted us to interpret the perpendicular lines, yeah? Hence, determine the coordinates of D, the point of intersection of the altitude, and they keep on using the word altitude. It's examiners, no? It's not fair. Big English for small learners. No, man. All right, so let's get the points of intersection. So the equation of this line, we need to find it. And then also the equation of this line, we already have it. So the only thing we need is the y-intercept, and then we have the equation. So we're going to say if we have y minus 8 is equal to a half into x minus 10. Let's open this up. It's going to be a half of x minus 5 plus 8, meaning that's a half of x plus 3. So this is the equation of that line. So a half of x plus 3. Now when I solve these two simultaneously, I'll have a half of x plus 3 is equal to -2x plus 13. Let's move the 2 that side. Let's move the 3 that side. So what's a half plus 2? It's 5 over 2x. When you move that side, we're going to have just a 10. So that's a 20. So 5x is a 20, meaning that x is going to be a 4. Then we substitute this 4 back into this equation and see that y is going to be a half of 4, which is 2 plus 3, which is 5. So these are the coordinates of D, 4 and 5. This question. Okay, so we move on. 3.2, they want us to get the area of ABC. So we know that area of a triangle is given as a half multiplied by the base multiplied by the height. So the only thing we need is to get the distance AB, okay, using the distance formula. Okay, so we had our beautiful coordinates, which was a 10 and 8, then a negative 10 and negative 2. Negative 10, negative 2. This was 10 and 8. We got D as 4 and 5. We have C as 11 and something, 11 and negative 9. So let me get the distances for those two, and then I'll find the area. So it's going to be x squared. That's going to be 10 minus 10 squared plus 8 minus 2 squared. Okay, so that's going to be root of 20 squared. I go 20 squared plus another 10 squared, which gives us 10 root 5. And then the CD, okay, it's going to be square root of 11 minus 4 squared plus, can say 5 minus 9 squared. It's the same thing. That's going to be square root of 7 squared plus, that's 9, which is a 14 squared, which is 7 root 5. So 10 root 5, 7 root 5, and then we just need to substitute into the formula of the area. Okay, so we know that the area is going to be a half times 10 root 5 multiplied by 7 root 5. So half of 10 is 5. 5 times 7, that's going to be a 35 multiplied by 5 again. That's 15 and 2, which is 17, which means it's 175. This is units squared. All right, then 3.3, they want us to get the size of A. By these people. We're saying this is 10 root 5. They want us to get this angle here. So there are two ways to getting this. It's either we get the distances BC and then AC, and then we use the cosine rule. Okay. Alternatively, since we already have this as a 10 root 5, I think this would be the quickest. We know that this is a 7 root 5. We can divide this into 2. So that this is a 5 root 5. And then remember this is a 90. So we can use our tan. Yeah, I think that's the quickest. Let's not use the cosine rule. So you're going to say that the tan of A is equal to the opposite, which is the 7 root 5, over the adjacent, which is 5 root 5. So 10 divided by 2 is 5. So root 5 and root 5 will cancel, meaning that the tan of A is basically 7 over 5. So A is going to be the arctan of 7 over 5. Okay. So shift tan 7 over 5. I'm getting 54.46. Okay, so if I use this kind of approach, it might give some sort of misleading information. Okay, so let me rather not use it, because for me to use it, it simply draws an indication to say that D is a midpoint of AB, and yet the question never mentioned anything of the sort. Okay, yes, we can have a perpendicular, but at a different, not necessarily at the midpoint way, okay? So I'm going to discard that, okay? I'm going to throw away that. So rather, what I'll do, if I use, because I need to find a distance, because that's the only way out for me to make life easy for myself. So let's get the distance BC. Okay, so if we find the distance BC, do we need a BC or just AC? Let's get AC. It's going to be easier for us. So when you substitute this AC, I should get something like a 7 square root of 10. Okay, that is the AC. 7 square root of 10. Now we have this, we have that. We need the distance BC again. Nope, we don't need the BC. We can use the area rule, whereby we know that the area, if we're focusing on the side of A, it's going to be area being a half multiplied by the AC multiplied by the AB, the sine of A. So we got 175 is equal to a half, our AC 7 root 10, multiplied by the AB, which we got as a 10 root 5, the sine of A. Okay, so when you do your magic, simply means that our sine of A is equal to 0.707, and then the shift sign will give us a 45. I think this is more reliable than the first one. All right, then we move on to question number 4. Question number 4, they're telling us a circle that has a midpoint, which is like the center. What are these people? Why are they like, no, man. It's inscribed in a triangle. AB is a tangent, P is that. A and B are the x and the y-intercepts of the tangent, O is the origin. Okay. The examiners, it's like they had an agenda. Inscribed, midpoint. All right, they want the equation in the form of that. So what we need to do is just determine the radius, okay, using the distance formula. So what we're going to do is, okay, so we need to get the distance PM. So under root sign, we shall have negative 18 over 5. We are subtracting a negative 2 squared. Plus 16 over 5, you're subtracting a 2 squared. So you punch that into your machine, you're getting just 2 units, okay? Then we just have to say that it's x plus 2 squared, plus we have y minus 2 squared, must give us this squared, which is like a 4. That's what the question wanted. And then 4.2. What is the mighty paper saying about 4.2? Okay, they want us to get the equation of the tangent. Now, whenever we find the equation of the tangent, we need the gradient. Okay, so we're going to say that the gradient of PM or MP. So change in y over change in x, which is 2 minus the 16 over 5 over negative 2 minus minus. This is negative what? 18 over 5. Okay, so when you simplify this, punch this, we're going to get a negative 3 over 4. So that is the gradient of the radius. Né? So gradient of the tangent is going to be the reciprocal of this with the negative sign. So it is a 4 over 3. Then we can say that y minus the 16 over 5 should give us the 4 over 3 into x minus minus the 18 over 5. Open up, make y the subject. So I'll end up with something like y minus 16 over that is equal to 4 over 3x plus probably that's going to be 6, which is like a 24 over 5. Okay, simplify further, we shall have a 4 over 3x. Okay, and then this is plus 8. So that is my answer for 4.2. 4.3, circle A is shifted 3 units up and then 1 unit to the right. And the radius is halved. So that we get a new circle. Can we write down the equation? Okay, so let's start by the 3 units up, 1 unit down, meaning that the x is gonna because if it's moved 3 units up, meaning that we're starting from here. So you're gonna subtract. We're gonna subtract, or we're gonna plus a 3, which is like a 5 here. And then this one, if we move it 1 unit to the right, it's going to be a -1. So meaning it's gonna be x plus 1 squared. And then this is gonna be y minus 5 squared. We say the radius is half. So if it was 2, then it's a 1. So 1 squared is 1. Okay, so that is what we end up with. Then circle N touches the tangent AB at R. We want to get the coordinates of that. So we have the equation. We have the equation of the tangent. So let's solve the two simultaneously. So where there is y, we just substitute this. Let me come this side and say that the equation of our circle, we said it was x plus 1 squared, and then y minus 5 squared is equal to 1. But the tangent was 4/3x plus 8. So where there is y, let's replace it with that. Okay, so you're going to have x plus 1 squared plus, this is 4/3x plus 8 minus 5 squared is equal to 1. Let's open this up. It's going to be x squared plus 2x plus 1. We open this up, it's going to be 16/9x squared, because this is going to be a 3. Then 3 multiplied by this is going to be 4 times 2, which is going to be like 8x. And then 3 squared is going to be 9 minus 1 is going to be a 0. Let's get rid of the denominator. Oh, let's collect the like terms first before we get rid of the denominators. Okay, so when we collect the like terms, this and that's going to be 25/9x squared. That and that is going to be a 10x. And then this one cancels that. We have a plus 9 is equal to 7. Multiply through by 9, 25x squared plus 90x plus 81 is a 0. Okay. And then factors, we're going to have a 5x plus 9. And then we're also going to have a 5x plus 9 equal to 0. So the roots here are equal, meaning that the value is going to be -9/5. So that is the x value. The question is asking us coordinates of R. So if that is your x, we just need to substitute into the equation of y, meaning that it's going to be 4/3 multiplied by -9/5 plus 8. And what does that give us? It gives us a 28/5, meaning that our R is a -9/5 and then 28/5. So that's what the question technically wanted. Okay, then we move on to 4.5, determine the ratio of BR to BP. Where is BR? So they told us there's another circle that is touching that. So BR. So let me just extend this. I don't know if it is just in the same, because we say the coordinates are basically -1, 5. So let's assume it is somewhere here. And then this is R. Okay. It could be even over passing that side, no stress, no problem. Okay, so they want us to get BR to BP. BR and then BP. So meaning that these are more like similar triangles. Okay, so what are the coordinates of BP? Or coordinates of B? Because we got this as our equation 4/3, we got that as 8. Ne? So if that is 8, we need to find this distance, and then we also need to find the total distance. All right, so first things first, we need to get the distance BR, ne? Using the distance formula. So with BR, we're going to have a 0 minus 9/5 squared plus 8 minus 28/5 squared. And then for BP, 0 minus 18 over 5 squared, plus we have 8 minus 16 over 5 squared. This is all under the root sign. So with the BR, we have a 3, and then with this, we have a 6. So in stock of BR over that, it is 3 over 6, which becomes just 1 over 2. Then what conclusion can we be made about the ratio Bn to Bn? We must give the answer. And so we know that if this is 1 over 2, automatically we know that NR and MP, okay, NR, because this is N, saying NR and MP will also be a half. So it's saying Rn over MP must also be a half, because those are basically radii of the same circle. And we can see that the two triangles are technically similar. Okay, so we can use that sort of conclusion, and then we can say that Bn over Bn is also going to be a half because of similar triangles. Okay, that is question number 4. Wow, what a question. Question number 5, which is trig. If tan 41 is t, write down the value of the following in terms of t. We need to reduce this. If possible, we can even draw a sketch. I prefer drawing a sketch, even if the question sometimes doesn't need one. Okay, so if that is a 41, we know that tan is opposite of adjacent, meaning that this hypotenuse must be 1 plus t squared under the root sign. All right. So 319, where do we find 319? Which quadrant is that? That is quadrant number 4. So 319 is the same as 360 minus 41. 360 minus 41. Good. It's the same as tan of 360 minus 41. And then the fourth quadrant, tan is negative. So it's the same as negative tan 41, which gives us a negative t. And then 82. So 82 is twice of 41, meaning that this is the sine of 41, but twice. So it's a double angle, meaning that's 2 sine 41 cos 41. But we know that the sine 41 is okay, then I'm multiplying it by the cos of 41, which is 1 over that, 1 plus t squared. Okay, so by the top, we shall have just a 2t over, when these two multiply, we just have something like a 1 plus t squared. So this is what the question basically wanted. And then lastly, they want us to get cos of 19 for 4 marks. Okay, so for us to get the cos of 19, we could look at some special angles. Which special angles can I look at, especially when I'm maybe focusing on the subtraction? Okay, what is 60 minus 41? Could be 19, yeah. So let me say that the cos of 60 minus 41, then I can use the compound angles and say that this is the cos of 60, cos of 41, plus the sine of 60, and the sine of 41. So we know that the cos of 60 is 1 over 2, and the cos of 41 is 1 over the square root of that. So 1 over root of 1 plus t squared, plus the sine of 60 is root 3 over 2. And then the sine of 41 is t over that beautiful 1 plus t squared. All right, so we can see that the denominators are basically the same, meaning that I'm only going to have 1 plus root 3t. I'm dividing it by 2, 1 plus t squared. So that is what I end up with as my final answer for that. Then question number 6. Question number 6, simplify the following. So reduction here. So let's see. 6.1. If it's doable. 6 out of 11. So 4 over 3. Saying 4 over 3. Okay, so 4 over 3 cos squared of 330 minus 1 over 2 cos squared of negative 45. We are subtracting 1 over 3, the sine of negative 30. So reductions of special angles. So where do we find 330? That's the fourth quadrant, which is 360 minus 30. But in that quadrant, the cos is positive. No? So meaning that this is going to be 4 over 3 cos squared of 30 minus, you know that the cos of a negative is the same as the cos of a positive. So this is not going to have any effect on that. So it's 1 over 2 cos squared of 45. And then pull out this negative. So it's going to be positive 1 over 3 sine of 30. Remember? Oh, they never told us that because they already said without using a calculator. Yeah. All right, so that's 4 over 3. We know that the cos of 30 is basically root 3 over 2. But this will be squared. Minus 1 over 2. We know that the cos of 45 is supposed to be 1 over root 2. But then when you square that, it's going to give us a half. Or you can say it's root 2 over 2. But it's just the same thing. 1 over root 2 squared. Plus 1 over 3. The sine of 30 is just a half. Okay, let's simplify with the squares. So it's a 4 over 3 multiplied by 3 over 4. Now, this is going to be a half. The 2 cancels the 2, which means it's just the 1 left. Plus, this is, we said, a half, not a third. It's going to be 1 over 6. Now, this cancels that cancels it. So 1 minus 1 plus 1 over 6, meaning that our answer should be just the 1 over 6. All right, so 6 marks done. Then 6.2, we need to prove that the sine squared of 1 minus cos is equal to that. You can do this very fast for 3 marks. No? Why can't we do it here? So we know that cos, let's use the identity, is the same as 1 minus cos squared theta over 1 minus cos theta. So we're starting from the left-hand side. So difference of 2 squares, 1 minus cos theta into 1 plus cos theta. Everything is divided by 1 minus cos theta. So this cancels that. Oh, there's a minus 1 there. Okay. Then we have 1 plus cos theta minus 1, which gives us what? Cos theta, which is equal to the right-hand side. All right, I was worried because I'd left out that negative 1. Okay, then 6.3. 6.3. What are we doing? We are solving for A, general solution. So we have sine 2. No, it's 2 sine squared A. Okay, this is 6.3. So 2 sine squared A plus sine A minus cos A must give us sine 2A. And then you're telling us that A must be, or sine of A must be greater than 0. In other words, it should be positive. Okay, so what can we see here? What can we see here? Let's move this on this side. So 2 sine squared A plus sine of A minus cos of A minus, let's just simplify that, 2 sine A cos A is equal to 0. Okay, so I'll push, I don't know which one to push and which one to, but it's just the same thing. I'll do the grouping. Okay, I can do the grouping here, this and that, and then all of this and that. So what's common? What is common there is going to be the sine of A. I have 2 sine A plus 1. What's common here, I'm going to take out the negative cos of A. I'll be left with 1 plus 2 sine A. So meaning that this bracket is common, which is 1 plus 2 sine A into sine A minus cos A is equal to 0. Okay, so how many marks? Should be like 6 marks, this question. Oh, it's 7. Hallelujah. Okay, so let's solve this. So with the first one, it simply tells us that sine A is going to be negative a half. In this case, we're going to say that the sine of A is equal to the cos of A, meaning that the tan of A is just a 1, okay? Now, after identifying something like that, since they told us that sine of A must be greater than 0, this is less than 0. So this is a not applicable kind of situation, or we're not going to use any solutions from it. Our focus is going to be this side. So let's get the reference angle by saying the shift tan of 1 should give us the A, which is like a 45. Okay, so we know that when the angle is 45, the sign is positive. That is quadrant number 1. In the second quadrant, we can have 180 minus 45, which is giving us 135. So in the first quadrant, we're saying A is going to be 45 plus 180 times K. K is an element of integers. Okay. And then with the second quadrant, it's going to be 135 plus 180 times K. K is an element of integers. But if the question want the exact values, we just said solve for A. Okay, so we can stop at it. We can stop at this, where we have the general solutions. All right, 6.4. Now they are twisting questions again. P is X and Y is a point on AB, whereby that angle is theta, the norm P is a rectangle, express BP in terms of Y and theta. BP, this one, in terms of Y and theta. So this is X, then this is Y. BP. Okay, so we can, which, they want it in terms of Y. So we're looking at the opposite and we're looking at the hypotenuse, which is the sine. So 6.4.1, we're going to say that the sine of theta is equal to the opposite, which is Y, over the hypotenuse, which is BP or PB. Then just switch or cross multiply, meaning that BP is going to be Y over the sine of theta. I don't know, that's what I'm getting. 6.4.2, hence can we prove that AB, where is AB? So this is Y over sine of theta. AB, this entire thing, must be given as Y over sine plus X over cos. Hello. Okay, so what I can see is that if this is a theta, even this will be a theta in a way. But now we're focusing on the bigger picture there. Okay? If this is a rectangle, if that's a Y, this must also be a Y. If this is X, then this is going to be probably M minus X. So what do we do here? What do we do here? So we know that this line is going to be parallel to that line, technically. So if this is a theta, we could also look at just this triangle alone and say that the sine of theta is equal to the opposite, which is AN over the hypotenuse, which is AP. Okay, meaning that our AP is going to be the AN over the sine of theta. But the question is focusing on the cos. I don't know, why am I using sine again? That sine is not going to help me. Let me use the cos pattern C. Let me use the focusing on ANP. Let's use the cos. So cos of theta is the adjacent, which is NP, over the hypotenuse, which is AP, meaning that your AP is NP over the cos of theta. Okay. But they told us P is what? X. So meaning that my interpretation of this X was wrong. The whole of this is X. So it's going to be X over cos of theta. So for me to get the AB is going to be the AP plus the PB. So the AP that we found was X over cos of theta plus the PB that we found was Y over sine of theta. Okay, question number 7. Question number 7. Telling us in a quadrilateral ABCD, these two lines are parallel, beautiful. AC bisects BCD. If our X is a B and then the C is 2Y. Now, if it's being bisected, simply means this is a Y. That's also a Y. Now, they want us to express DAC. DAC in terms of Y. So we know that DAC is going to be a Y. Okay. DAC is going to be a Y. Why? Because those are alternate angles. No? And then ADC. So if this is a Y, that's a Y, meaning that the ADC is going to be 180 minus 2Y, the angles in a triangle. So 180 minus 2Y. All right, then 7.2. Are we able to show, okay, that AC, this one, is given as this? So let's use they say A, this is A. So let's use the sine rule and say that A over sine of Y should give us AC over the sine of 180 minus 2Y. Our focus is the AC, so we're going to multiply that side. So our AC is going to be A. When we simplify that, that's going to be sine 2Y over sine Y. I think that's what the question wanted. You don't need to break that down further to give us A equals Y. Then can we show that AC will be given as this? So we're seeing sines all over. Okay. AC is having a BC. So we already found our AC to be A sine of 2Y over sine Y. Now, if this is a Y and then this is X, meaning that this angle here is going to be 180 minus X plus Y. Okay, because you add that and that to give us, okay. They want us to show that AC is still that. So what I can do, we have a BC of interest, and then that, okay, perfect. So I'll say that AC over we have the sine of X is equal to the BC over the sine of 180 minus X plus Y. So make AC the subject. So you're going to have a BC sine of X over, when you reduce this again, we're going to have just the sine of X plus Y. Okay, perfect. Then can we show that BC is given as that? So let's equate the two equations of AC. So BC sine of X over sine of X plus Y is equal to our AC that we found as 2. We got it as A, not 2. It's A sine 2Y divided by, we got the sine of Y. Okay, let's do the cross multiplication and leave this on one side. So you're going to have A. Let's break this down, which is going to be like a 2 sine Y cos Y. And now I'm multiplying it by the sine of X plus Y. And then I'm dividing it by the sine of Y and the sine of X, because this must go down, this must go up. So this cancels that, meaning that we have our 2a cos y, the sine of x plus y, and then we're dividing this by the sine of x. Okay, so that is what we have for that particular question. All right, question number 8, which is the trig functions, are telling us that the diagram below represents two graphs of trig between 0 and then 180. Then can we identify these functions by writing it in the form of da. So we know that 8.1, when you look at the f, between 0 up to 180, it's just in this format. So this looks to be like a sine graph, because must just finish up this up to 360, and then you're done. The maximum is a 190, and then that. So what I'm going to end up with, it should be just a simple sine x. Okay. Then with the g, from 1 to -1, it's 180. That's going to be -180. Oh, so it's a negative, meaning that it should be a negative cos of x, no? By the look of things, because it is flipping. So if I have to extend this, it should be in that sort of format. So negative cos x. Then the range of g. So range is basically the y values for which the graph is valid. So it's going to tell us that -1 is less or equal to y, less or equal to +1. Then the period of f is just going to be a 360. Then the amplitude of g is just a 1. That's the maximum displacement that we can ever get. And then for which graphs will this and that be less than 0? So between 0 and 90, okay, we're saying that if this is a positive and this is a negative, so the graph of f is decreasing while g is above. Graph of f is decreasing in this section while g is above. So from 90 up to 180. Okay, so we're seeing that. That's number 1. So 90 up to 180. Okay, and then if this is a negative and this is a positive, so the gradient is increasing while this one is below. Increasing while the other one is below. F is increasing while below. So between 0, okay, so we can see that even between 0 up to 90. So it's the same as the entire thing actually, between 0 to 180. I don't know why we should break it down. So 0 to 90, 9 to 180. So even if somebody says 0 is less x and less 180, it will still be perfect. It would still make sense, okay? It would still make sense. Okay, so that is what we're going to say. But then remember at 90, both graphs are equal. Is that true? No, it's way far away. It's not. Okay, so that is 8.5 and question 8. Then question 9, we have our, does it look like Euclidean? Yes. AE is a tangent to the circuit O, or circle OD. AC is a straight line. BD or DCD are drawn. Okay, there we go. 9.1, what do they want? If B1, okay, is a 5, 7, can we give reasons for ODE? ODE. So we know that this is a 90. Tangent perpendicular to the radius. So ODE is a 90. Reason, radius perpendicular to the tangent. 9.2. 9.2. They want us to get D3, this angle here. So for us to get D3, we know that this is a 57. We know that all of this is a 90. Then we can get this to be a 33. So start by getting C2. So tell us that C2 is a 33. Those are basically angles in a triangle. Okay. And then we're going to say that D3 is going to also be a 33. The angles that are opposite equal sides. Okay, so that is what we have with that 9.2. Okay. Then someone could also look at it in a different way. What do we mean in a different way? If they can find D1, then they have found C1, which is the same as the D3. Okay, so if that is a 57 for D4 here, using the turn code. Okay, so D4, someone could say that D4 is a 57, meaning that 90 minus 57 gives us that. So either way, you'll get the same answer. Then they want us to get C2. So this is a 33. Must get C2. Oops, this other angle. Oops. So we're going to say that our C2 is going to be 180 minus 33 angles on a line, or adjacent supplementary angles. So 180 minus 33 is giving me 147. So that is how quick I would have obtained that for 4 marks. Because one, I've already clarified that my C1 was a 33. Who said C2, man? We said C1, not C2. We say something else, we're writing something else. Okay, C1 is a 33, then yeah, so you get the 4 marks for that. Alternatively, somebody could find D2. Then after getting that, you focus on the exterior angle. You plus this 57 together with this 90. Does it make sense? Yes. 57 plus 90, we should get 147. And then you focus on the exterior angles of a triangle. Okay, so that is another way to kill this question. Question number 10, you must prove the angle at the center being twice angle or the circumference. Can we prove that theorem? So step number 1, construct. Okay, construct a line in that matter. So tell us that draw the line KO. Draw the line KO, produced to a letter maybe T. Produced to T. So what that does is it breaks this into 2. So if that is 1 and 2, okay, then we're going to say that O1 is the same as, if I also break this down into 1 and 2, it's going to be K1 plus L. Okay, reason, those are exterior angles of the triangle. So this and that will be the same. But, okay, we know that but K1 is the same as L. Those are angles that are opposite equal sides, meaning that our O1 is going to be twice of K1. We do the same using that other triangle and say that our O2 is the same as K2 plus M, exterior angle of a triangle. But we know that our K2 is the same as M, angles opposite equal sides, okay? Because we know that this is the same as that already, meaning that our O2 is going to be twice K2. All right, then we know that O1 plus O2 should be the same as 2K1 plus 2K2. So twice K1 plus K2 is the same as this angle, LOM, okay? Which means that LOM is the same as twice K1 and K2 is the same as LKM. So that is what we get for that particular question. All right. So those are the 5 marks for that question. And then 10.2, O is the center of the circle. So whenever they give us the proof question, chances are high, whatever follows should be an application, okay? So then, if XY is a tangent, okay, the circle y, x, p, q, yo, and y is still straight lines at that. Let me just do this. Okay, and then y1 is m. Okay, this is m. All right, so 10.2.1. Did I skip a question? No, I haven't. I haven't skipped a question, not at all. Okay, so the first question, can we write down with reasons the other angles that are equal to m for 3 good marks? Wow. Wow, let's get these 3 marks. Okay, they want 3 angles with reasons. Okay, so I'll say this is 10.2.1. So which other angles are the same as m? Number 1, we have T1, because that is like a tan chord. Okay, this is m. Then, which other angle do we see? What did they tell us? XY is a tangent. They told us that PX and PY are the same. So this and that will be the same. So if that is true, meaning that the angle X is also M. Angles opposite, equal sides. So this is also M. So we have this one. Then which other angle can we look at? Do we have a butterfly somewhere? I guess so, because I'm seeing this and that and that and that. Meaning that if we have this, no, it's not coming out the way I want it. It's not coming out the way I want it. Okay, so let's look at the circumference. Let's look at the circumference, because this one is at the circumference. This one is at the center, which is going to be like 2m. We need another angle. They said 3 or 2. I might be doing a whole lot of things yet. Oh, they said 2. Oh, thank goodness, because we're going to sleep here looking for another m. Okay, write down with reasons 3 other angles that are equal to 2m. Oh, we've already found one. So O1 is 2m. Hallelujah. So it's 2m. Reason is going to be angle at the center. Must be twice angle at the circumference. So if that is 2m, okay. Tangents and what? Do they make sense? We need to look for another angle. We need to look for another angle. So if this is that and that is that. So what is T? No, that's not going to make sense for me, because T is not going to work for me. Let's look at P3 and see. P3, would that make sense? Where I look at this angle. Yeah, it would make sense because it is exterior to these two. So we're saying P3 is going to be 2m. That is exterior angle of triangle XYP. Okay, so this is a 2m. Do we have any parallel lines? No, we don't have parallel lines. So we need to look for the last one, which now brings me to the bow tie. It is this and that, same coordinate or angles in the same segment. So it means T2, this angle in this one will be the butterfly or the bow tie. So T2 is 2m, angles in the same segment or angles subtended by the same chord. So that is what we needed for 6 months. Hallelujah. We move on. Question number, last one. ABC. Okay. ABC is acute angled, that is inscribed. Again, big English. CF and BE are perpendicular. CF and BE are perpendicular. Oh, wait a minute. What did I do? They said CF and BE are perpendicular to BA. Where is BA? CF, okay, and BE. This one. They're perpendicular to that and perpendicular to that. Okay, CD is the same as DB. Okay, already given. OA is produced, custard, the circle, G is drawn. Beautiful. Let's see. What do you want now? Question, what do you want? Can we prove that AFDC is a cyclic chord? AFDC. Okay, so if this is a 19, this is also 19. I want us to prove that this thing is a cyclic chord. So remember, with the cyclic chord, only thing we need to prove is that opposite angles are supplementary. We need to also look at the exterior aspect and also focus on the bow tie. Okay. So 11.1, we're going to say that D3, okay, this is going to be a 19. Why? So D3 is a 19. Where can I write that? Let's put it here. D3 is a 19. Line from the center bisecting the chord must be perpendicular to the chord. So line from the center, or we can say the perpendicular bisect. Oh, is that correct? No. It's a line from the center bisecting the chord. That's perpendicular to the chord. Okay, so if that's a 19, are we going somewhere? Then we know that F3 is a 19, which is given to us. And if that is true, so if this is a 19, this is also a 19, then we have the bow tie. Hallelujah, that is done. That is done. And we're saying that since D3 is equal to F3, therefore AFDC is a cyclic chord. We're using the converse of angles in the same segment. Okay, so that is that. And then can we prove that C2 is the same as C3? Can we prove that C2 is the same as C3? So in other words, they want us to prove that this line bisects those two. Okay. So what we need to do is, what is C2? We know that C2 is going to be the same as A1. Okay, since we've just proved the bow tie kind of approach. So C2, let me just use this. Okay, C2 is the same as A1. Okay, because of that. Then, in the same respect, we can say that A1 is the same as C3 because of, again, the bow tie. There's another bow tie, this one, this and that. But since we proved that this is a cyclic chord, then this and that will be. So now, since we've seen that the both of them are that, then C2 will be the same as C3. Oh, we need to give reasons now. It's going to be angles in the same segment. Same story, angles in the same segment. And then we move on. We move on to 11.3, can we prove that ABD will be similar to CGD? Let's see. ABD. Where is ABD? ABD. ABD, this one is similar to CGD. To CGD. Similar to that. Okay, so let's highlight what we see from the two triangles. Let me just put it in. So one thing I know is that the whole of this D4 is the same as D2 and D1. Those are vertically opposite. We know, because when you are proving this, you need to use angles, strictly angles. Now we saw that this is the same as this, meaning that this should be the same as this entire thing, B1 and B2. Okay, so we're saying that B1 plus B2 must give us G. Those are angles in the same segment. Then we're saying that D1 plus D2 must give us a D4 vertical angles. And then we say C3 is equal to C1. We've proved that in the previous question. Therefore, CGD is similar to ABD because of angles. All right, so that is how we prove that. And then lastly, 11.4, can we just sort that out? So we know that in the triangle OCD, GCD, because these are the triangles we're focusing on, okay? We're saying OCD, how is OCD a triangle? It is, Malumi, because we're focusing on this. Because this is also similar to those two. Okay, there's a 90, this was a 90, this was a 90, those are the same. This was the same as that. And then which means this will also be the same as that. So we know that those two triangles are similar. So what we're gonna say? What are we gonna do? What are we gonna say? Because it is 6 marks. Can say that C2 is the same as C3. We've proved that. We've proven that one, okay? Then D3 is the same as D4. Okay, what is the reason for that? Say D3 is the same as D4, angles on a line, which is also a 90. Okay, angles on a line. Then CD will be also CD, which is common, meaning that the two triangles are congruent. Therefore, we're saying OCD is congruent to CGD. So the same thing. So if that is true, we're going to say that AB over CG should be the same as BD over DO. Okay, so that is what they needed, because if the two triangles are congruent, then these two sides are equal. Boom. Okay, guys, out of 100, I can rate this paper to H because of the big English and, let's give it a 95, guys. It wasn't that bad, but it was fair. Okay, so guys, I'll stop there. I wish you all the best in your preparation. Let's meet when we look at the memo of other provinces for paper 2. Bye-bye. Hello, welcome you to this episode where we shall be looking at the proposed memorandum of Limpopo, grade 12 mathematics paper 2 for June 2025. Okay. Now, with this paper, we have 3 hours for 150 marks, and then the paper has 11 questions. Wow. Why so many questions? Okay, so the others are just basic instructions of paper 2. Then question 1, which is the statistics. Now, for some provinces are not including statistics within their scope for their own reasons, okay? But in Limpopo, we had statistics there. But of course, statistics that will be just the grade 11 and grade 10 statistics are not necessarily the grade 12 statistics. Okay, so with the first question, they're telling us that a certain grocery store's delivery service has grown over the past 2 years. And then the store owner did a survey on a specific day to improve their delivery performance. And then the following table represents this. Okay. All right. So we have the delivery time and then the performance, the number of deliveries. And they want us to complete the cumulative in the answer book. So I'll just put the cumulative just down here. So the first cumulative will always be the first frequency. Then 8 plus 5 is a 13. 13 and 12 is a 25. 25 and that is a 40. It's a 43. 43 and 22, that is a 65. 65 and that's going to be a 90. That is 110. 125, 135, and then 140. That's my last cumulative. How many deliveries did we have altogether? Let's see. They never told us. That's weird. But it's fine. Let's take the 140 to be our last cumulative that we're getting. Then 1.2, they want us to draw an ogive to represent the information. How many classes do we have here? How many classes do we have? We have 1, 2, 3, 4, 5, 6, 7, 8, 9. Wow, 10. Okay, so I'll just try to sketch an ogive this side and see. Okay, so if we have this as our, let's use this color. Perfect. That is our cumulative. And then we can have the time in this format. Okay, so we know that the deliveries started at 8. Okay, so we can have this as 8. And then we can have 9, 10, 11, 12, 13, 14, 15, 16, 17. The last delivery was 18. 1, 2, 3, 4, 5. I don't need to count them. Yeah. Okay, so whenever we are plotting, okay, let me indicate this side. Our maximum cumulative is 140. So I can use 20, 40, 60, 80, 100, 120, and probably 140. All right. I'm sorry if the intervals are not that clear. It's just that it's a sketch. So we just need to have the shape. So whenever we are plotting, we said we only use the upper class intervals. Okay. So 9, 10, 11 up to 18. So 9 is going with 5. So I'll say 9 is 5, which is somewhere there. And then 10. Okay, 10, we're going to take a 13. And 13 is still below 20, which could be somewhere there. And then we have 11, which is a 25, slightly above 20. Okay, and then we have 12, which is a 43, slightly above 40, somewhere there. Why does it look like a line for me? Okay, then we have 65, slightly above 60. Let's have it somewhere there. Okay,